We have some conversions that can take us from Cartesian to polar coordinates. We have r squared equals x squared plus y squared. We have tangent of theta is y over x. So let's go ahead and use these for part A. We have x is -3, y is 0. So r squared equals -3 squared plus 0 squared. That's 9. So we can let r equal 3. And then we have tangent of theta is equal to y over x. So that's 0 over 3. So that's 0. And so, of course, tangent of theta is equal to 0 in lots of different places. So we just need to look at where we are. -3, 0 is at an angle of pi. And so that's the one that we use. Of course, we could flip and use theta equals 0 and r equals -3. That would be fine as well. But we'll just go ahead and use this. And then for B, we have r squared equals square root of 3 squared plus -1 squared. So that's 3 plus 1, that's 4. So we'll let r equal 2. And then we have tangent of theta equals y over x, so -1 over root 3. Okay, again, we have multiple places where that's true. If we look at our unit circle, well, tangent is negative in quadrants 2 and 4. Of course, this quadrant here is positive x, negative y. So this is in quadrant 4. So if we choose an angle down here, then we'll be good. So -1 over root 3, that happens when theta is equal to, let's see, negative pi over 6. And so then our coordinate then is r theta to negative pi over 6. Okay, now we want these in two different ways. So let's go ahead and flip around. If we flip the r value to a negative, then that just adds pi or subtracts pi from the angle, and so we can put a 0 there. It's funny that polar coordinate is actually the same as the Cartesian coordinate. And then here we can put a negative in front of the r, and then add pi to this, and that gives us a 5 pi over 6. And so those are our two different ways for each of these coordinates to represent these in polar coordinates.